Now let us solve some examples based on the powers of I. Here we have to evaluate the value of I raised to 42 plus I raised to 63 plus I raised to 37. Now here just to recollect the fact that if we have I raised to 4n where the power of I is a multiple of 4, then we know that it is always equal to 1. Now if we consider the power which is 1 less than some multiple of 4, the answer would be equal to minus I. If you have 2 less than some multiple of 4, the answer is minus 1. And finally if we have 3 less than some power of 4, then answer is 1. Now alternately, if we have some power which is 1 more than the some multiple of 4, then that is still also equal to 1. So we can have something like 4n plus 1. This is also equal to 1 only. So looking at the power, we will be able to evaluate the value of the corresponding term. Now if we consider I raised to 42, it is 2 more than I raised to 40 and I raised to 40 is 1. So therefore additional 2 in the index will make it I square. Now here I raised to 63 is, if we consider 63 as 3 more than 60, and since 60 is a multiple of 4, I raised to 63 is effectively same as I cube. And lastly I raised to 37. 37 is 1 more than 36 and 36 is a multiple of 4. So therefore I raised to 37 is nothing but same as I. Now we know that I square is minus 1, I cube is minus I, and we have plus I. So I gets cancelled and we have minus 1 as the answer. Now let's see the next question. Here we have to evaluate the sum of I raised to n, where n varies from 1 to 200. So that means what we have to evaluate is I raised to 1 plus I square plus I cube plus I raised to 4 plus so on up to I raised to 200. Now here if we see that the powers of I are cyclically repeating in batches of 4. So therefore from I raised to 5 onwards up to I raised to 8, you will get the same set of 4 values of the powers of I. And similarly if we work backwards from I raised to 200, we have I raised to 199, I raised to 198, and just before that we have I raised to 197. So these last 4 numbers also having the exactly same value of the first 4 powers. So that means now let's consider the sum of each particular set of 4 powers. So we know that I raised to 1 is I, then I square is minus 1, then I cube is minus I, and I raised to 4 is plus 1. So therefore if we see that I gets cancelled and minus 1 also gets cancelled. So therefore ultimately we have sum as 0. And hence we are going to get the same sum in all the groups of 4 consecutive powers as shown here specifically. So therefore ultimately the sum of all these numbers will be nothing but 0. Now let's see the next example. If x is equal to 3 plus I, then evaluate x cube minus 3x square minus 8x plus 15. And now here if we directly substitute x with 3 plus I in the given expression, then it will become a bit tedious to evaluate. And there is another interesting shortcut method by which we can get the value of the expression in a much quicker way. So for that what do we do is, we first bring 3 on the left hand side and keep only I term on the right hand side. And now let's square both sides so that I square will become minus 1. And on squaring x minus 3 we have x square minus 6x plus 9 is equal to I square, as we know, is minus 1. So therefore bringing that minus 1 on left side we have x square minus 6x plus 10 is equal to 0. So we have this useful piece of information which we will use in evaluating the given expression. Now in the given expression, if you see from the first three terms, if we take x common, then in the bracket we will have x square minus 3x minus 8 left and plus 15 as it is. Now we try to adjust this expression in the required expression so that wherever we get x square minus 6x plus 10, we can replace it with 0. So now here we have x into, let us write the required expression, that is x square minus 6x plus 10. This is what we want to adjust. Now since we have minus 3x and here we have minus 6x, we must add 3x and then subtract 18 to maintain the balance. Now this part becomes 0, therefore we are left with 3x minus 18 plus 15. So on expanding we get 3x square minus 18x plus 15. Now once again let's take 3 common because we want to adjust that quadratic expression. So we get x square minus 6x plus 5. Now we can put slightly different way to this particular method, that is, since x square minus 6x plus 10 is 0, x square minus 6x can be considered as minus 10. So replacing that we have 3 into bracket minus 5, which finally gives us minus 15 as the answer. So here the important idea was to bring all the real terms on one side and keep only I term on other side and then square, so that square of I becomes minus 1.